Can a polynomial's degree explain algebraic numbers? Imagine trying to understand a complex puzzle by looking at just one piece. Sometimes that piece, like the degree of a polynomial, can tell us a lot about the bigger picture. Today, we're exploring whether the degree of a polynomial can explain algebraic numbers. First, let's talk about what a polynomial is. It's an expression made up of variables and coefficients, with the highest power of the variable determining its degree. For example, the polynomial x squared minus 2 has a degree of 2 because the highest power of x is 2. The degree tells us how many solutions or roots the polynomial might have, especially over the complex numbers. Now, an algebraic number is any number that solves a polynomial equation with rational coefficients. For example, the number square root of 2 is algebraic because it satisfies the equation squared minus 2 equals 0. The key idea here is that every algebraic number is a root of some polynomial with rational coefficients. But among all these polynomials that an algebraic number satisfies, there's a special one called the minimal polynomial. This polynomial is monic, meaning its leading coefficient is 1, and it can't be factored further over the rational numbers. The degree of this minimal polynomial is what we call the degree of the algebraic number. It's like the simplest polynomial that captures the essence of that number. For example, rational numbers are algebraic numbers with degree 1 because they satisfy linear equations like x minus a equals 0. The square root of 2 has degree 2 because its minimal polynomial is x squared minus 2. If you look at more complicated algebraic numbers, like roots of cubic or quartic polynomials, their degrees are 3 or 4 respectively. This degree isn't just a number. It tells us about the complexity of the algebraic number. It indicates how many steps or layers of polynomial equations are needed to describe it. It also helps in understanding the structure of the field extension generated by that number over the rational numbers, which is a fancy way of saying how the number fits into the bigger universe of numbers. So, to answer the question directly, yes, the degree of a polynomial does explain algebraic numbers. It provides a way to classify and understand these numbers based on the simplest polynomial they satisfy. This connection helps us see how polynomial degrees relate to the properties and complexity of algebraic numbers, making it a fundamental idea in algebra and number theory.